So if we want to find the direction of a force experienced by a wire which is placed in a magnetic field, we'll always use Fleming's left-hand rule. Like in this question, uh, this is a multiple choice question. The question is which arrangement will cause a force in the same direction as original. Like in this one, the force is downward. We want to work out which others the force is downward. Now let's start with P. Okay. So in P, your first finger or your index finger of your left hand. Remember, when you're finding a force on the wire, you will use a left hand. So your index finger or your first finger will always point. Your index finger or the first finger will always point towards south, the magnetic field. So your index finger for this figure, your index finger will point in this direction. Okay. Your second finger represents the direction of the current, which direction the current is going. The current is going in this direction. So your first finger is pointing towards south and your second finger is pointing towards the screen. Which direction your thumb is pointing? What is the direction of your thumb? Up or down? Which direction, when you apply the rule, your thumb is pointing? Just apply the rule, use your left hand. Your index finger is pointing towards south. Your second finger, if you're not able to understand, you can just let me know. So I will explain. But if you're able to apply the rule on the figure, then mention which direction your thumb is pointing. Yeah, what's the direction of the thumb? So when you are applying the rule here, your index finger is pointing in the direction of a magnetic field. So your index finger is pointing towards south. That's the direction of a magnetic field. Your second finger represents the direction of the current, which is pointing into where your thumb is pointing. Your thumb is pointing upward. So if your thumb is pointing upward, means this P will experience an upward force. So force will be upward. What about Q? For Q, we'll again use the rule. Your index finger, your first finger represent the magnetic field. So in this case, the magnetic field, because the south is towards right, so your magnetic first finger pointed towards the south. Your second finger represent the direction of the current. Which direction the current is moving? The current is moving in this direction. Where your thumb is pointing when you apply the rule. Yeah, which direction your thumb is pointing? Is it up or down? So when you apply the rule here for the second one, your index finger is pointing in the direction of a magnetic field, which is south. Your second finger represents the direction of a current, which is pointing out. And where your thumb will point upward. So the second one, the force is also upward. So we have an upward force for the second one as well. Now, when we apply the rule for the third one, your first finger or your index finger represent the magnetic field, which is south. Your second finger represents the direction of a current where your thumb is pointing now. What's the direction of a thumb? So when you apply the rule, your index finger is pointing in the direction. Your index finger is pointing in the direction of a magnetic field. So which is towards the south. I'm talking about R. Your second finger represents the direction of a current which is going out. So we rotate our wrist. Index finger is pointing towards south. The second is representing direction of the current where thumb is pointing. Thumb is pointing downward. So in this case, it will experience a downward force. So in the R will only experience the downward force, rest all of them will experience upward force. So the question was which one match with the original? So that is D. Because in case of D, so even you can understand with a simple, the reason for choosing this question and explain, this is an MCQ, multiple choice question, but this also have a concept. What is the concept here? If we change the direction of a current, the direction of a force will change. Even without applying a rule, I can just apply the idea and I can get the same result. If I change the magnetic field, the direction of the force will change. If I change the current, the direction of the force will also change. But if I change both of them, then the direction of the force will be same. As you can see here, in P, what we change the magnetic poles only. So if we change the magnetic poles without applying rule, I can say the force will also change. In Q, what we did, we changed the direction of the current only. Compared to the original, the direction of a current, so the direction of the force will also change. But in R, what we did, we changed both of them. So if we change both of them, then the direction of the force does not change. So if we change one, then the force will change. But if we change both, then the force does not change. Here in this question, we have an alternating current. If we have an alternating current, it means the current is changing a direction. Like first the current is going in down and then the current is going up because AC current changes the direction. So if the direction, first, what is the direction of the force experienced by this wire? According to the given point position, if you want to find the force on this wire, what we'll do, we'll use a left hand rule. Index finger is pointing towards south. Second represent direction of the current and thumb is pointing towards me, or it will be out of the paper. So means the force will be out of the paper. If the direction of the current will change, the direction of the force will also change. If the current is going up, we are not changing the magnetic pole, so the force will be into. So as a result, what will happen when this wire is placed in a magnetic field and the direction of the current is changing, so the direction of the force will also change. So when the direction of the force will change, so as a result, the force of a wire alternate between one direction to the opposite. What does it mean? Like first the force is outward, then when the current change, the force will be inward. That's why A is the right answer. Why not B? The force on the wire is constant in size and direction. Wrong, because it's not constant in size. It's not constant in direction because the direction is changing. There is no force acting on the wire. That's wrong as well. The wire will not experience a force when it is parallel to the magnetic field. If the wire is carrying a current and it's parallel to the magnetic field, then there is no force on the wire. But it's perpendicular, then it will experience the maximum force. There is only a force on a wire when the current is reversed. No, it's not like when the current is reversed, then there's a force. The current, when even current is there, it's not reversed, there will be a force throughout. If there is a current, there is a force. Is it clear, this question?
Yes, sir, clear.
A current carrying wire X and Y lies in a magnetic field between the two poles of a U-shaped electromagnet. The force act on a wire because of a magnetic field. Each of the following action is carried out separately. The current in X and Y is reversed. Look, I will explain the idea that this wire, there's a wire which is X and Y is carrying a current, and this is an electromagnet. Okay. The electromagnet produce a magnetic field like north and south, and the wire also produce the magnetic field and interact and experience a force. Now they're saying the current in X, each of the following is carried out separately. The current in the wire X and Y is reversed. If we reverse the direction of a current, what happened to the force? The force will also be reversed. The magnetic field is reversed. If we reverse the magnetic field, the force will also be reversed. Both the current and the field are reversed, then there will be no effect. Because if we change both of them, then it won't affect. If we change one of them at a time, then it will be. So how many of these actions cause the direction of the force on the wire XY to be reversed? How many actions will cause the direction to be reversed? You can use the chat to answer this. So two of the actions, yes, that's right. Two of the actions will cause, because if I change the current, the force will change. If I change the magnetic field, the force will change. But if I change both of them, then the force does not change. A wire is placed in a strong magnetic field. When a current is passing through a wire, it moves upward, means the force is upward. The current is reversed. In which direction the wire will move? We just changed the current. So what happened to the force? That will also be reversed. So which direction this wire will move now? If it was moving upward in the beginning. Use the chat to answer. So if we change the direction, the wire will move opposite. But if we change both of them, then the wire will move in the same direction. The diagram shows a current carrying conductor in a magnetic field. Which arrow shows the direction of the force on the conductor? Like which direction it will experience a force? First, this is a positive and negative. So the conventional current will move in this direction. You apply the Fleming's left-hand rule, your index finger or first finger pointing towards the magnetic field, which is from north to south. Your second finger represents the direction of the current where your thumb is pointing. Which direction your thumb is pointing. You apply the rule and find which direction your thumb is pointing. Is it upward, downward? Look, B and D are totally wrong because all should be 90 degree, the current, the wire, and the magnetic field. All should be 90 degrees. So it cannot be B or D. So you're left with only two options, either A or C. So the right answer for this, when you apply the rule, A will be the right answer. The diagram shows a current carrying wire 90 degree. So this is the direction of a current. Magnetic field is into. So when the magnetic field is into, which direction the force will act? So we use the Fleming's left-hand rule. Your index finger is pointing towards the magnetic field, which is into your finger, index finger. My index finger is pointing towards the screen. My second finger represents the direction of the current. So the current is towards the right-hand side. where my thumb is pointing. So when I apply this rule, my thumb is pointing upward. So if my thumb is pointing upward, in which direction does the force act? So yeah, that's right. The force will act towards the top of the diagram. Because when you apply the rule, your index finger is pointing into, second represent the current, and thumb is pointing upwards. When a current carrying conductor is placed in a magnetic field, it experiences a force. Which statement about the force is correct? Remember one thing, force, magnetic field, and the current all should be perpendicular or 90-degree to each other. So it is parallel. No. So the force, magnetic field, and the current, they are all perpendicular, because like if the current is in this direction, the magnetic field this direction, so the force, so they're all 90-degree to each other. So it is perpendicular to both magnetic field and the direction of the current. So this is illustration of a left hand which helped to describe the force on a wire. So the thumb is representing a motion or a force on the wire. What index finger, the first finger represent? Index finger represent the magnetic field. And what the second finger represent? It represent the direction of a conventional current. Is it clear? This topic about the force on a wire and the use of the left hand. So today we discuss about how the
Yes, sir. Clear.
straight wire produces a magnetic field, how a solenoid produces a magnetic field, and how to work out the force experienced by a wire which is placed in a magnetic field. Next session we'll do some like we did MCQs, lot of MCQs, but structure question next session we'll do on this topic, like how you will be able to answer these questions.